Have you ever imagined like showing a computer just a couple examples and then suddenly it learns a new skill?
Hmm.
That's the idea behind this in-context learning. And that's what we're going to be looking at today.
Okay.
Um, and you've given us some really fascinating research on this
Yeah.
that looks at how these transformer models work.
Right.
So these are sort of like the engines
Hmm.
behind some of the most impressive AI that we see.
Absolutely. Yeah.
So especially the language stuff.
Yeah. The research you sent is it takes a really smart approach.
Okay.
It looks at a simplified learning task and a kind of streamlined model architecture.
Okay.
And that really helps isolate what's going on as these AIs are learning.
Gotcha.
It's like setting up a perfect experiment to see what makes them tick.
And one of the things I thought was so interesting was how this research looks at different types of data
Yeah.
and how that impacts in context learning. So like how similar the examples are, how varied they are.
Yeah.
But there's one detail that really stood out to me, which is something called an induction head.
Right.
I mean, it sounds like science fiction.
It does have that kind of a ring to it, but it's a key piece of the puzzle.
Okay.
The induction head is really what makes this zero-shot copying possible.
Okay.
So imagine you see some kind of pattern for the first time,
Mm-hmm.
and you just immediately know how to continue it,
Yep.
even though you've never seen that specific sequence before.
Gotcha.
That's essentially what's going on here.
So before we get too deep into the weeds, maybe we should take a step back and make sure we're all on the same page about the difference between in-context learning and in-weights learning.
Yeah, for sure.
Yeah.
Absolutely.
Oh,
So in weights learning, that's the classic way that AI models learn.
right.
You give the AI a ton of data, and it changes its internal parameters.
Uh-huh.
It's like fine-tuning a really complex machine.
So like studying a textbook and memorizing the rules.
Exactly.
Like
But then
that.
you've got in-context learning.
Right. And that's more like learning from watching someone else do something.
Yeah.
You just see a few examples and you just figure it out.
Mm-hmm.
So the AI can make these predictions about a new task just by seeing a few examples.
Wow.
It doesn't need to go through all that massive adjustment.
So that's really different.
Yeah.
Okay, so in this research, how did they show how different characteristics of the data impacted the AI's ability to learn in context?
Well, one of the things they found was that this thing called burstiness is really important.
Okay.
So when you see a lot of examples of the same type all grouped together,
Okay.
that actually helps the model learn better.
Oh, interesting.
So it's like, imagine you're studying for a test, right?
Okay.
It's easier to do a bunch of similar problems in a row
Yeah,
rather than jumping between different types of problems.
that makes sense.
Yeah, it's like the AI is recognizing a pattern and saying, oh, okay, I'm getting the hang of this.
Gotcha. So like recognizing a pattern is really important for this kind of learning.
Absolutely.
Another cool thing they found was that having more classes.
What do you mean by classes?
Yeah, so think of those as different categories or types of things to learn.
Okay.
So if you have more classes, it actually makes in-weights learning harder.
Oh, that's interesting.
It can actually boost in-context learning.
Okay, so that's like opposite.
Yeah, totally.
Wow, okay.
So it's like if you were trying to memorize the rules for a bunch of different board games all at once, that
Yeah,
would be really hard.
which
Right.
would be very hard.
But if you could focus on mastering just one game at a time
Uh-huh.
by just watching someone else play,
Yeah,
that would be way easier.
yeah, that's a really good point.
Yeah. And so with more classes, it seems like the AI is forced to come up with a more general problem-solving approach.
Right. So it's like the difference between learning one specific font
Yeah.
and being able to identify the letter no matter what the handwriting is like.
Exactly.
Interesting.
But
Okay.
then building on that,
Yeah.
even within a single class, a bit of variation actually helps the model generalize better.
Oh, interesting.
So it makes the model rely more on those in-context examples.
So it's not just about seeing the same thing over and over again. It's like seeing
Yeah.
it in different ways.
Yeah, a little variation helps the AI kind of separate the signal from the noise.
So it's like learning to recognize a cat, not just from one picture,
Mhm.
but from like seeing pictures of cats in different situations.
Yeah.
Like different poses, different fur patterns,
Right.
different environments.
Exactly. It helps you understand the core concept of what a cat is.
Yeah, like the essence of cat.
Yeah. Rather than just memorizing a specific image.
Okay, that's a really great point.
One more data characteristic that they looked at was something called the Zipfian distribution,
Zipfian distribution.
which sounds a little complicated.
Yeah, it does a little bit.
But basically, it just describes this pattern where you have a few things that happen really frequently,
Okay.
and then a lot of things that happen really rarely.
It's like the Pareto principle.
Yeah, exactly like that.
Right.
And so the cool thing is that this distribution seems to benefit both in context learning and in weights learning.
Interesting. So it helps both.
Yeah, it's
Yeah.
like the AI is finding a good balance
Okay.
between specializing in those frequent things, but also developing a broader approach
Gotcha.
for those less common ones.
That's really cool.
Yeah.
Okay, so we've talked about all this different stuff with the data,
Yeah.
but can we go back to that induction head that you mentioned?
Sure.
And like really unpack how it works?
Yeah, so remember, the induction head is all about that zero-shot copying.
Yeah.
So being able to predict outputs, even for inputs the AI has never seen before.
So like predicting the next letter in a sequence? Even if it's a totally new sequence?
Precisely. And the research, they lay out this really clear 4-step process
Okay.
that explains how this happens. And there's this great visualization that goes with
But I'm
them.
picturing it now.
Yeah, it's like following a recipe for zero-shot copying.
Gotcha.
So in the first step, the AI focuses on a specific token.
Okay.
Now, a token you can think of as a unit of information.
Okay.
It's like a letter or a word.
Gotcha.
And it pays attention to the token that comes right before it.
Okay.
So it's trying to figure out the relationship between those two tokens.
So it's like the AI is saying, okay, if I see this symbol,
Right.
I need to look back and see what came before it to figure out what comes next.
Exactly.
Interesting.
And then in the second step, things get really interesting.
Okay.
This thing called the value matrix of the first layer comes into play.
The value matrix. Okay.
Yeah. So you can think of that as a way of representing the importance of different pieces of information.
Okay.
And what it does is it actually copies the content of that previous token into a special buffer subspace.
A buffer subspace, so like a holding area.
Yeah, exactly.
Right.
It's like a temporary storage space for that key piece of information.
So it's like taking a mental snapshot of that previous token.
Yeah,
value.
and storing it in a special mental compartment.
Interesting.
All right, then in step 3,
Yeah.
you have the target token,
Okay.
which is the one we're actually trying to predict. And that target token, it matches its content to the stuff that was stored in that buffer subspace.
So it's like it's comparing notes with what it just learned.
Exactly. It's like, is this new information consistent with the patterns I just saw?
Right. Okay.
And then finally, in the last step,
Yeah.
the value matrix of the second layer,
Okay.
it writes the content from that buffer subspace onto the target token.
Wow.
And this allows the AI's classifier.
Okay.
So that's the part that's actually making the prediction.
Gotcha.
To say, okay, based on everything I've seen, this is what should come next.
So it's really like this copying mechanism that's enabling it to learn from these examples and apply that to new situations.
Exactly. It's like the AI is piecing together a puzzle.
Okay.
And it's using the examples as a guide.
Now, one thing that I found really interesting is this idea of an abrupt transition.
Yeah.
So what is that?
So that's one of the most fascinating things they found.
Okay.
There's this initial phase where the model is slowly getting better. It's like gradually improving.
Right.
And then all of a sudden, bam,
Wow.
it jumps to near perfect accuracy.
So like a light bulb moment.
Exactly. Like a light bulb goes off in the AI's mind
Gotcha.
when that induction head clicks into place.
And they used a really helpful analogy to explain this, which I really liked.
Yeah.
So tell me about that.
So imagine you're a hiker and you're trying to find the lowest point in this mountainous landscape.
Okay, I'm picturing it.
Yeah.
I'm in the mountains.
All right, so that initial slow learning phase is like you're walking along this plateau.
Okay.
You're making progress, but it's slow and steady.
It's gradual.
Right, and then that abrupt transition.
Yeah.
It's like you suddenly find a cliff and you just drop straight down to the valley floor. Zero loss, perfect accuracy.
I love that analogy.
Yeah, it's a good one.
So it's not just about slowly going downhill.
Right.
Sometimes you need to like take a big jump to get where you need to be.
Exactly.
That's a great analogy.
Yeah.
I love that. So it sounds like there's more to it than just like random chance.
Right.
That causes that jump.
Exactly.
So is there something more deliberate going on within the AI?
Yeah, so what they think is that the slow initial learning phase might actually be really important for guiding the model towards that cliff.
Oh.
It's like laying the groundwork.
Okay.
So think of it like learning the basic moves in chess before you start trying to strategize several moves ahead.
Gotcha. So those plateaus aren't wasted time.
Right.
It's like building a foundation.
Yeah, exactly.
So to really understand this abrupt transition, they looked at some specific progress measures that they were tracking in the data.
Right.
So what were those?
Yeah, so one of the measures they tracked was how much attention the AI was paying to the labels that were actually present in the examples.
Oh, okay. So it's like the AI is learning to pay attention to the right cues.
Exactly.
Gotcha.
And as you might expect, that ability gradually improved during that initial slow learning phase.
So it's like the AI is figuring out what to focus on.
Yeah, and what they found was that at first the AI was just sort of randomly picking one of the labels.
Mm.
So it was better than random guessing,
Okay.
but it wasn't true understanding.
So like trying to solve a jigsaw puzzle just by randomly putting pieces together
Perfect
and
analogy.
hoping something fits.
Exactly.
Okay.
But here's where it gets really interesting.
Okay.
They also tracked the AI's attention to the correct label in the context.
Okay.
And guess what?
What?
That attention only spiked right at that abrupt transition point
Oh, wow.
when the model suddenly achieved high accuracy.
So it's like the AI has this aha moment
Yeah.
where it suddenly realizes, oh, this is the key.
Exactly. And that really supports the idea that the induction head is playing a crucial role.
Okay.
It's like the induction head is the missing piece
Gotcha.
that lets the AI connect the dots and actually learn from the context.
So it's not just about paying attention.
Right.
It's about paying attention to the right thing.
Exactly.
Okay.
And to test this idea further, they actually did something really clever.
Okay, what did they do?
They created a scenario where the AI couldn't rely on that gradual learning of contextual labels.
Okay. How did they do that?
So they made sure that all of the possible labels were always present in the context.
Oh, so they took away that initial strategy
Exactly.
where it was kind of randomly picking.
Right.
Oh, that's interesting.
And so in this new scenario, some of the models did still manage to learn the task,
Oh,
but it took them way longer.
oh wow.
And some of them even got stuck in a less than ideal solution.
Interesting.
So it's like they were wandering around that plateau,
Uh-huh.
but they could never find the cliff edge to jump down from.
Wow.
And so this really reinforces the idea that that initial learning phase,
Yeah.
even though it seems inefficient,
Mm.
might actually be really important for
Okay.
the AI to develop a really good in-context learning strategy.
So those early fumbles are actually setting it up for success later on.
Exactly.
That's really cool.
Yeah.
Okay, so we've talked about in context learning the induction head,
Uh-huh.
these abrupt transitions,
Right.
but how did they actually model and analyze this whole process?
Yeah, so they used a few different approaches.
Okay.
One was to create this really simplified mathematical model of the induction head.
Okay.
And this allowed them to see how all the different parts of the induction head interact with each other.
So like building a miniature version of the
Yes.
induction head to study.
Uh-huh.
Interesting. Okay.
And by tweaking different parameters in their model, they could see how those changes affected the learning dynamics.
Okay.
And what's really cool is that their simplified induction head,
Yeah.
when it was paired with a basic classifier.
It was actually able to reproduce all of those data dependencies that we talked about before.
Wow. So they were able to capture the essence of in-context learning
Right.
in this much simpler model.
Exactly.
That's really cool.
Yeah.
Another approach they used was to analyze the loss landscape of the induction head.
Right.
So are we back to the rolling hills and valleys again?
We are.
Okay, great, because I love that analogy.
It's a good one.
So remind me, what does that represent?
Yeah, so the landscape analogy helps us visualize how the AI is learning.
Okay.
And remember, the loss represents how far off the AI's predictions are from being perfectly accurate.
Right. So the lower you are in that valley, the better you're doing.
Exactly.
Okay.
And what they found was that this landscape is not smooth and gradual.
Uh-huh.
It's actually filled with cliffs and plateaus,
Okay.
which explains those abrupt transitions.
Gotcha. So it's not just a steady downhill stroll.
Right.
Sometimes you got to take a leap of faith
Exactly.
to reach that low point. And they argue that those initial slow learning phases might actually be essential
Okay.
for guiding the AI towards those cliffs.
Interesting.
So those plateaus are actually providing the momentum for those big leaps forward.
It seems like those plateaus are really important then.
Yeah, they're not just wasted time, they're actually a crucial part of the learning process.
Okay.
And what's really exciting is that these insights from these simpler models
Yeah.
could have big implications for how we understand and develop those much larger, more
Yes.
complex language models.
The ones that are like already out there in the world.
It's not the ones that are transforming AI.
Yeah.
And so by understanding these fundamental principles,
Uh-huh.
we can really unlock the full potential of AI.
Okay, so it's not just about building bigger and faster AI.
Right.
It's about really understanding how it works
Exactly.
and how it learns.
Yeah. And by doing so, we can help AI learn, adapt, and solve problems in ways that we never thought possible.
It's so exciting to think about where this is all headed.
It really is.
and what we can accomplish with AI in the future.
Absolutely.
So this is all really fascinating, and it makes me wonder about, like, what are the implications for this kind of learning? I mean, we've been talking about this very specific task,
Yeah.
this zero-shot copying idea.
Right.
But what about more complex forms of learning?
Right.
Can AI really learn like we do, just from a few examples?
Yeah, that's the million-dollar question.
Right.
And the research really just scratches the surface here.
Uh-huh.
It looks at this very specific type of in-context learning that really depends on pattern recognition
Okay.
and this kind of copying mechanism.
Right.
Whether similar mechanisms are at play in more complex situations,
Okay.
like understanding language or reasoning, that's still very much an open question.
So, like, those large language models that
Yeah.
can write poems and, like, hold conversations and things like that.
Right.
They're probably using, like, a combination of approaches, right?
Yeah. In context and then traditional learning.
Yeah, think of in-context learning as, like, a tool for adaptation.
Okay.
It lets the AI pick up on new patterns quickly and adjust its behavior based on the situation.
Gotcha.
But for really deep understanding
Okay.
and being able to come up with new ideas, you probably still need in-weights learning,
Okay.
where the AI is actually refining its model based on tons of data.
So it's like the difference between mimicking an accent
Yeah.
and actually understanding the language.
That's a great way to put it, yeah.
You can sound similar on the surface,
Right.
but to be fluent,
Uh-huh.
you need more.
Exactly.
Okay, that's a really good analogy.
Yeah, and this brings up another important point,
Yeah.
which is that as these AI systems get better at learning from limited data, we need to really think about the potential consequences.
Right, like what if they learn harmful or biased patterns
Yes.
from the data?
Yeah, that's a huge concern.
I mean, things could really get out of hand. Absolutely. Researchers, developers, policymakers, they're all thinking about this right now.
It's good that they're thinking about it.
Yeah, it's really important because as AI becomes more advanced and more integrated into our lives, we have to be really careful about how these learning mechanisms are used.
So it's like, with great power comes great responsibility,
Exactly.
even when it's in the form of code.
Right.
Yeah.
We can't just get excited about the cool stuff
Right.
without thinking about the potential downsides.
Well, this has been a really fascinating deep dive.
I agree.
Before we wrap up, is there any final thought that you want to leave our listeners with?
Yeah, the next time you're talking to a chatbot or a language AI,
Okay.
I want you to ask yourself,
Yeah.
is it really thinking like we do? Or is it just really good at copying and adapting and recombining what it's seen?
Interesting.
And if it is just mimicking, how far can that go?
Yeah.
Can AI ever be truly creative and intelligent? Or is there something fundamentally different about us?
Those are great questions to think about.
Yeah, I think they're worth pondering as we move into this age of AI.
I agree. And on that note, I think that's a great place to wrap up.
Okay.
Thank you so much for joining us on this deep dive into the fascinating world of in-context learning.
Yeah, this was fun.
Until next time, keep exploring, keep learning,
Yeah, absolutely.
and keep asking those tough questions.
For sure.